All right, kind of a little nuance with these 2D stereo drawings. And I've definitely gotten questions about it both from instructors and from students. And so here's my short answer in response to when it comes to that first carbon, is the axial up or down? Now, the way I was taught it, the way I teach it, is that the first atom, the axial position, is up. And where this comes from is if I build my cyclohexane ring and I try to convert what's basically a 2D line bond drawing, so this flat ring here, into a three-dimensional 2D projection of a three-dimensional structure, is I'm going to pucker this carbon up, and I'm going to push the carbon adjacent opposite to it back down. So in doing that, sorry, it's not wanting to behave today. In doing that and popping the top one out, one of these atoms sticks up and the bottom one, axial position, points down. And so for me, was how I was taught, is that this ends up going up because when you take this ring and you pick up that top corner, that's going to end up pushing the hydrogen up into the axial position. And now, by the rotational symmetry, these two axials are up and axials will alternate up, down, up, down, up, down. Now, are there textbooks that define it the other way? Yes, they will define this axial position as being down. They will say it's down, up, down, up, down, up. Where does that come from? Well, instead of popping this ring up, you pop the top down and you bring the bottom up, and this will give you this conformation. Is one more right than the other? And the answer is no. Really, if you just take this drawing and rotate it 180 degrees and do the same thing with 2D, you'll end up flipping all these positions. So if I rotate this 180 degrees, I end up with the drawing I started with. So why do I prefer having the first one up? Well, for me, I always define this carbon as number one. And we'll talk about in another video how different books define what the number one carbon is. But for me, this makes the most sense, again, probably just because that's what I was taught, is that that's the number one carbon. That one's going to pop up, and that makes them up, down, up, down. Are you wrong if you flip them? The answer is no, but to understand that because you have changed which carbon is up in this 2D drawing, you've inherently changed what your starting carbon is. And by changing your starting carbon, you've kind of rotated the ring around. So as long as the relative positions are correct, meaning that if you have this group up and this group down, we turn around, we're just going to basically get the same, let's say we have two methyl groups that are 2 carbons apart. They should still be 2 carbons apart, clockwise or counterclockwise, depending on what you've drawn. So as long as you have the correct spatial orientation that's just related by a rotation of this ring, meaning that you're just taking it and you're turning it, you are still correct. But you will also see textbooks that disagree over whether this axial is up or down. Again, I teach it up because I teach this as the first carbon and it comes out when we go to the chair conformation. Other books don't teach it that way, and also other books define the number one carbon differently. So hopefully this kind of helped you out here in understanding why different books can kind of give you slightly different answers or give you different positions. Again, with these 2D drawings, we can get rotations, we can get lots of things that will give us what look like different answers but are really the same answer.